So we're doing homework for tonight, and we're trying to figure out exactly what they were trying to ask us to do. So we will do a couple of examples here and show you exactly what they were asking you to do. So you might want to take these notes. I'm going to do PEL 2, and I'll put in the S and the P and the D and the F, and then we'll see what that totals to. So if we look on our periodic charts that I gave you, and let's get that on the screen for you, not here, here. This periodic chart will tell you exactly how to figure this stuff out. Now I'm going to do principal energy level 2, and we know the principal energy level by the number on the left-hand side. You're all pretty good with that by now. So principal energy level 2 is easy, but now how do we figure the other stuff? Well, we look at the 2 here, and if I see a 2, that's in principal energy level 2. So we know we have an S. We look in the P's and go to the P block, and you look for the 2P. Yes, there is a 2P. Is there a 1P? No. Okay. Is there a 1S?
Yeah.
Yes. Okay. So the 1S, of course, is up here. It's kind of the combination of these two atoms, the hydrogen and the helium. Now, let's say we were asked about principal energy level 4. Do we have an S? Absolutely. Is there a 4S?
4S?
Or 4P? D. D. 4D. Do we have a 4D? It's not on the line you expected, is it? No, it's down here. Okay? So the 4D is down here, so you have to hunt for it in each block. So if we're doing principal energy level 4, we want to find the 4 in the D block, and it's there. We want to look for 4 in the P block, and it's there. And then we want to see if there's a 4 down in the F block. And by golly, that guy is there. So all 4 are there. And what this question is asking is if we have a full energy level, full principal energy level, how many electrons could there be in that principal energy level? And if you get your upside down triangles and look at those, you're going to see exactly what they're asking you in this particular question. So let's go ahead and, oops, went the wrong way. Let's go ahead and fill this guy in. Did we have an S in the principal energy level 2? Yeah. And how many are in the S's? 2. That's 2 possible. Not necessarily 2, but 2 possible. How many do we have possible in the P? 6. Okay. And was there a D for principal energy level 2? No. So that's a 0. And did we have an F? No. So that's also a 0. And our total for this is going to be 8. Okay, let's go principal energy level 5. We got an S possible, a P possible, a D possible, an F possible, and we're going to get a total. Okay, let's look at it, and oops, check it out. And so let's see. We got, what were we doing? 5, right? Okay, 5 is here. So, first of all, we look in the S block and see, do we have a 5? Indeed, we do. Now we look in the D block. Do we have a 5? By golly, we do. And do we have 1 in the P's? Yes. And now we look down in the F's. Do we have a 5? Whoops, didn't want to move that. Control Z. Let's go down here. And yes, we have a 5F. So we have them all. And so we can come back here And now we put in how many for an S? You see, it doesn't matter the principal energy level, does it? If it has an S, it's going to have 2 possible. We had the P, how many? 6, and the D's? 10, and the F's? 14. By golly, look at that. Okay, so we got 32 total. Are you getting the idea of how to work that one?
Yes.
Some of you don't. I know you don't. And so that's why we're going to get into groups in just a minute and work it out. But this periodic table, this form of the periodic table, is going to answer all your questions for you. Let's get this back up. Okay. Whoop, wrong way. And now let's go down and let's talk about that second question. And the first thing you want to do is do this wave here. Boy, that's so dark it almost looks black to me. What color is that?
Dark navy blue. Dark blue.
I think it's a dark blue. I think it's a dark blue.
Dark blue.
Yeah. Really, really dark blue. Can you see it better now?
Yeah, it's blue.
Okay, cool. Anyway, so the amplitude, we're going to want to take some notes on that, so please get down. I call that the anatomy of a wave. As you're doing your anatomy of the wave, the first thing you want to notice is the wavelength. Okay, the wavelength starts here and continues over to here. Notice that it starts at the origin, which is this line, and then it goes up above. That's the positive amplitude. See, this is amplitude, the distance between the origin and the top of the wave, or the origin and the bottom of the wave. Both of those are amplitude. And I drew my wave very badly. I hope you draw yours better. Your wave on the bottom should be the same distance from the origin as the top guy is. So your positive amplitude and your negative amplitude should be the same. But I didn't do it very well, so I'm not that great an artist. Now, the thing that you need to realize about waves is that we talk about them in terms of time. And the time could be per second. It could be per hour. How do we measure speed in an automobile? What per hour? Miles per hour. Or if you have an English version of a car, then you'll have what per hour? Kilometers, sure. Okay? And your kilometers numbers will be more than twice the number that you would have in miles. So you multiply your miles by 2 point, I forget what, and I think it's 2.2, and that will give you your miles. Or kilometers, I'm sorry. So for time, now let's look at some waves. Let's look at this wave first. Okay, we have up, down, and back up. That's one wavelength. So how many waves do I have on that particular picture? Number one. Huh? Yeah, we have 2. I'm going to cover that just to make it easier to keep your eyes focused. And then the second wave comes up and down and up. Now how about this guy? How many waves do we have in this period of time?
2.
Why does it look so different? What's changed?
The altitude.
Yeah, the altitude, which we call the amplitude. Yeah, so the amplitude is smaller on this guy than it is on this guy. So smaller amplitude, but same wavelength. And how about this guy? Here we go. See if you can figure out how many before I get there. That's one wave.
4.
2 waves. 3 waves. And 4 waves. Okay, so this has got 4 waves in the same period of time that this guy down here has only 1. Yeah, that's right. It started with a negative amplitude, and then it went up and then back down. Okay, so it doesn't matter where it starts as a dip or a rise, it's still going to give you half a wave between where it leaves the origin and where it gets back to the origin. Are we cool with that? So now your job is to figure out down here what is the answer for each of these 4 questions. Okay, we'll do A, B, C, and D. And notice that it is possible to have 2 answers for the largest amplitude. And I'll go ahead and stop the recording. All right, Aaron, tell us on the principal energy level 3, do we have an S?
Yeah.
Okay, how many in there?
2.
2. Excellent. Do we have a P?
Yeah.
Haven't you written this down?
No, I did the other one.
Why didn't you do this one? Think I had already done it?
No, I didn't see it.
Get out your periodic chart. We're going to do that together.
Yeah.
How many are going to be in the P?
6.
It's always the same, yes. Okay. Whoops. All right. How many do we have in the D?
10.
Yes. And do we have an F? Is there a 3F?
0.
Okay. You look down in the F block, and you will see that there is a 4 and a 5, but there is no 3. Okay, so our total for this guy is 18. Notice this is a lot like your upside down triangle, and you're going to see the numbers go up and stay there, and then they're going to come back down. Okay, that's the way that works for the periodic chart. Okay, next one we're going to do is principal energy level 4. And so that's going to go to Andronic. Let's have you do that. Okay, Andronic, for principal energy level 4, do we have an S sublevel?
Yep.
How many?
2.
Good. For principal energy level 4, do we have a P sublevel?
Yeah, 2.
And how many?
6.
Good. Do we have a D?
Yep. 10.
Okay. And do we have an F? Is
Yes,
there a
14.
4F at the bottom? Yeah. Okay, so the way you do these guys is you look on this form of the periodic whoops, wrong way. You look on this form of the periodic chart, and what we were just doing was 5, wasn't it? Was that 5?
No, it's 6.
6. 6? No.
4.
No, we were doing 4. Okay, so for 4, we look in the S block first to find if there's an S. Then we look in the P block to find if there's a 4P, and there is. Now, the 4D isn't where you expect it, but if you look in the block called D, the D block, you'll find a 4D. Okay, and then down here, you look in the F block, and you find that there's a 4. So that's how we should be looking to find these guys. And, oops, one too many. There we go. Okay, so our total here is 32. So you see, as we've been doing these, let's get this guy at an angle, and so we had an 8, 18, 32, and 32. Okay, Vince, 6?
2 for S,
Good.
6 for P,
Uh-huh.
0 for D,
Okay, no D's?
no D.
Okay. Are you sure? We're in 6. Oops, sorry.
D,
6.
I don't know.
I sure see a 6. Here, right here.
1D,
Not 1D. We're talking about here. What we're talking about in this whole exercise, how many total possible electrons can we have in the 6D?
and it's 10D.
Yes, it's 10. Yeah, you got the right idea. But now we look down on the F block,
There's 0.
and that is a 0. Yeah, okay. So, whoops, back. And so, we are doing this in red. Let's finish it off in red. So you said 10, correct? And the F is a 0. And so as we look at this guy, the total is going to be 18. Yes. All right. Good, Vince. Looks like you kind of know what you're doing. And let's go on. And how about floor? Okay, floor. And let's do principal energy level 7. What do we have?
There's 2S.
Okay, 2 in the S and
There's 0P.
0P?
Yes.
Ah, okay, I know why you think there's 0, but there is a P. And the reason for that is that that chart that I gave you and the chart on our wall and even the chart in our textbook, I think. The chart in our textbook has it. Okay, if you look on the inside back cover of the textbook, you'll see 114, element number 114. And that guy hasn't been named, but somebody has actually made him. So that opens up the possibility for the P's. And so this guy would have P, and the total possible, if there is a P at all, is going to be 6. So our number would be 8. And now if we look at what's going on here with all of this stuff, we went 8, 18, 32, 32, 18, 8. The upside down triangle all over again. Okay, so on the upside down triangle, what I did was I went through all of the principal energy levels, found them in this chart right here, and added them up and put the right number of orbitals in there to show you the right number of electrons possible with 2 per orbital. Okay, so that takes care of that particular question, and now let's go back and let's look at the bottom part of this and see if we can get that figured out. And let's put this up so we don't get junked up with the other one. And let's look at wavelength and the anatomy of a wave. Let's take our little pointer and notice between this line right here and this line right here, we have a certain period of time, which I was trying to make roughly the same as the period of time on each of these little guys. Okay? So all of these are going to represent the same period of time. So which number, 1, 2, 3, or 4, is going to be most representative of what I've drawn? One wave. Which one has one wave? 4. Yeah, right. Okay, and so the wave starts at the origin, usually goes up. Now the wave down here was a down, but either way, it's the amplitude. And so the amplitude is your distance from the origin to the peak of the wave, or the origin to the trough of the wave. Okay. So we've got our wavelength, we know that now, we know the amplitude, and we know the time. And so we're going to go ahead and answer the questions, and I know that's a review, but I thought I would do that anyway. And let's go ahead and answer our questions with Anahit starting. What do we have for the longest wave, Anahit? Just look up here, Anahit. You don't need your paper even.
Oh, the longest is 3.
Is number 3?
Yeah.
That's the longest wavelength.
Oh, 4.
4, yes. Okay, in 4, we have the same wavelength as my demonstration up here that we labeled. So that's our longest wavelength. What would you say about the frequency of this wave, Anahit? Is it going to be more frequent or less frequent than the other 3?
What?
Correct. Okay, longer wavelength, smaller frequency. Smaller frequency because in the same period of time, this one biggest wave only hit us once. Now you're standing at the ocean and you get hit by one wave, normally you're okay. However, if you're standing in the ocean and you get hit by 4 waves, and let's call this period of time 1 second. Okay, in 1 second you get hit by 4 waves, you're going down. All right? Because you're getting 4 times the energy. 4 waves is 4 times the energy in the same period of time. What if you got hit with 20 waves in 1 second? You're toast. You're not just down. You're done. Okay, for good. All right. Or if we increase the amplitude of the wave at the ocean and you're standing on the shore and you get hit by a 30-foot wave. That is not going to feel good. Nor will the result of the wave hitting you result in something that you would like to have. Okay, so we got our longest wavelength, so that's good. Next up, Ray, how about it? What do we have for the greatest frequency?
3.
Yes, greatest frequency, because we have our shortest wavelength. Very good. And largest amplitude, and let's have that one for Anthony. What? No. You as Anthony, yes. Okay, I'm sorry? 3, that's one of them. 3 and 1. Yes, they both have the same amplitude. And here, let's do it. Watch. See? They both hit the line at the same point. All right. So the amplitude is the same. Whoops. I didn't want to do that. The amplitude is the same for both of those guys. And now, shortest wavelength. That goes to Anna. What's our shortest wavelength?
2. 4.
That's our longest wavelength.
3.
Did you write it down?
I put it 4.
Okay. Then you put it absolutely backwards. Okay. Wavelength. 1 wavelength. Okay. Wavelength. 1 wavelength. Shorter. Yes? Okay, this is shorter than this wavelength. And it's shorter, of course, than this wavelength because these two both have exactly the same wavelength. Okay, this is just a smaller amplitude. And that's it.